In this topic, we will be mainly focusing on how we will be able to determine the sanitary quality of a drinking water. That is the topic that we will be discussing today. So here you can see what are the important points regarding this. One is access to good quality water is like a universal human right. So when a country is governed by a government, its most important responsibility is always providing clean drinking water to the people of the country. If the government of the country is unable to provide that clean and safe drinking water, most of the time people will consider that government as a failure. So if there is no water, people may not be able to live. So clean water, clean drinking water is almost like a human right. Access to good quality drinking water in right quantity and at the right time is still a dream to be achieved in many urban and rural areas of our country. So that is a main important problem facing many people in our country. If you check in chat GPT, you can see that how many people in India are getting clean drinking water. You will have a check on that. So here you can see that people, especially living in cities and municipalities, most of the time they are well connected with the government. Political people are staying there. So most of the time people living in cities and rural areas will be getting enough drinking water. But at the same time people living in rural area may not be So if you check here, you can see that what is the actual number of people who are getting clean drinking water. You can see that. So here now situation is better. 98 to 98% of India have access to basic or improved drinking water sources. That is a very good thing. So earlier that was not the case, and here also you can see that only 4% of the households in 2024 are reported getting water of drinkable quality. So at least 98% of the people are getting some kind of drinking water, but at the same time 4% of the household. Then that is the amount. Then another statistics by Jal Jeevan Mission provides that 80% of the rural household, that is the tap water connections are provided to nearly 80% of the rural household. So situation in India has improved a lot from the previous years. So that is a great achievement. See here you can say access to improved water 98%, rural access to improved water. So and most of the households are getting at least some kind of tap water. So in India situation has improved a lot. So that may be because of the improved growth and development in India. So especially when people are living in a rural area, they may not be always getting the clean drinking water. Most of the time they may be getting their water from sources like river, pond, lakes, springs, tube wells, etc. So these are the primary sources of water availability for people who are living in rural area. So the most of the time it may not be a big problem. Rarely in certain areas of our state, like you can see the Kasargod, you might have heard about endosulfan problem. So only in such area drinking groundwater or tube water or pond water may be risky. Otherwise in most of the areas of Kerala, drinking this pond water may be safe also. So quality of these water sources is often threatened from agriculture runoff and industrial waste. So that is a major problem. Luckily in Kerala now the industries are very limited. But if you go to other country, other states in India, especially Maharashtra, Gujarat, etc., most of the time these industrial people will be expelling the wastewater into the river. Even in Kochi area, sometimes you might have heard that Periyar, in the fish population in Periyar might have died due to the waste pollutants expelled from various industries. So these kind of problems are always there. Otherwise, if the water, unless the water is contaminated by any kind of industrial waste or agricultural waste, most of the time this water will be perfectly okay for drinking. Now the qualitative and quantitative measurements are needed from time to time to constantly monitor the quality of water from various sources. So here you can see what are the primary sources. One is the bore well. Bore well contamination may arise from pollutant entering water table or sewage entering the borehole. So this is how the bore well is not so common here. But if you go to the North India, there are many places in North India where bore well is so common. Then municipality supply could be contaminated. If you know that how our water, Kerala Water Authority people are laying the pipes, even if there is some leak, most of the time they are very slow to come and repair it. If there is any leak, bacteria from the soil can enter into the water pipe. So that is why Kerala Water Authority people are always chlorinating water, because chlorine will be present in water for some amount, some weeks even after the chlorination. So that is an advantage. So that is why this is the primary reason for entry of microorganism into the municipality supply. Then what are the procedures we can do for checking the quality of the water? That is what the primary aim of how we can determine in the sanitary quality of the drinking water. So here there are 3-4 different types of tests are available. One is a physical test. In the case of physical test, most of the time like temperature, color, etc. These are under the physical test. Most of the time we will be able to detect it by our eyes itself. Then chemical tests are there, and there are some kind of chemical, mainly the chemical test will be checking for the presence of organic or inorganic minerals and also other organic substances which are present in the water. And thirdly, we have also bacteriological test. The purpose of the bacteriological test is to detect for the presence of bacteria or especially fecal bacteria which are surviving in excretory matter. Such kind of bacteria has to be checked. So these are the 3 primary tests which are commonly conducted for testing the quality of water. Now we will see what are the tests which we will be conducting under the physical, chemical. Under the physical, we will be checking for turbidity, palatability, conductivity, total, dissolved solid, and organoleptic properties. See here you can see what are the important physical tests we will be conducting. So under the physical test, here you can see that mostly it is about the color of the water. If the color of the water is just plain and clear, we can say that the water is of drinking quality. So color in water may be caused by minerals like iron. If too much iron is present in water, the color of the water will be red, and manganese will be there. Then so many substances which are present in vegetables like algae, weeds, etc. They can also enter the water and change the color. If too much algae is there, the color may turn into green. So color is one indicator. So color test indicate the efficacy of water treatment system. So that is how so if the water is of clean, clear color, then we can assure that that water is of good quality. The second test is turbidity test. Turbidity in water is because of suspended solid and colloidal. Suspended solid means if, for example, when you are putting tea powder into a glass of water, it turns into brown color or deep red color. The reason is that tea particles are suspending in the water. You put certain sand into a glass of water, it turns a deep brown because these soil particles are suspended in the water. So any solid particles which are suspending in the water will be increasing the turbidity. So by turbidity, what is the problem with the turbidity? When there are a lot of suspended particles in the water, the sunlight may not be able to pass through it easily. So that is the main problem in the case of turbid water. So turbid water will not be allowing the photosynthetics. That is, water will, for you take a pond water will be containing a lot of algae. So if algae has to undertake photosynthesis, So if there is no availability of sunlight, what happens is that algae may not be able to carry out the photosynthesis. So that is the problem with the increasing turbidity. So growth of microorganism may be affected. Then high turbidity makes filtration also expensive. That is another problem. So when we are checking for the water quality, if the water has too much suspended particle, it means that our time we have to spend more efficient systems for removing those suspended particle. That means that the cost of filtration will be more. So that is the problem when water has a higher turbidity. If sewage solids are present, and pathogens may be encased in the particle, escape the action of chlorine during disinfection. So another problem is that if there are too much amount of suspended particle, microorganism can hide in the spaces, so that even if we are chlorinating, these microorganism may not be dead. So that is increased suspended turbidity reduces the effectiveness of water treatment. So that is a relationship. More turbidity means less effective the water treatment mechanism become. So this is an idea of then odor. Odor means smell, odor and taste of the water. The presence of living microorganism. For example, you take a water from a polluted stream. The smell may not be very appealing. Smell may not be suitable for drinking. So that is a odor or smell. Then decaying organic matter. If any kind of plant or animal remains are decaying it, the smell of the water as well as taste of the water will be changing. So that also indicates that water contains many pollutants like ammonia, phenol, halogens, hydrocarbon. So all these will be rendering the water not suitable for drinking purpose. So that is so by simply looking at the odor, taste, color, turbidity, etc., we will get a reliable indication. For example, when you go to a forest area, what kind of water you will be see. You look at the water and you find that the water is very clean. You take a little water in your hand. If you find that it is clean, very clear, most of the time you may not feel any problem. But at the same time, if the water is brown or yellowish in color, we may not drink it. We will think that their water contains a lot of pollutants. So that way, by physical tests are most of the time can be conducted with our eyes itself. So these are the main type of physical tests. Then total dissolved solid means how much amount of suspended particles are there. Then what kind of organic particles are there. Then next level is the chemical test. Under the chemical test, these are the main parameters which we will be checking: pH, dissolved oxygen, chlorine, radionucleotide, organic and inorganic particles. Then here you can see the pH. Coming to the pH, the presence of selected group of chemical parameters, bio is a highly toxic chemicals, and BOD. These are the main parameters which we are checking in chemical test. So about the pH, normally you have studied about that pH of 7 is the neutral pH. So if the water pH is 7, we can feel that water is of drinkable quality. But if the pH is 4, it means it is highly acidic. If the pH is above 8 or 8.5 or 9, we can feel that it is alkaline. So a pH of above between 6.5 and 7.5 is most of the time is the preferable water. So pH is an indicator of relative acidity or alkalinity of the water. Values of 9.5 and above indicate that high alkalinity. Values of 3 and below indicate acidity. So as the pH value decreases, acidic nature increases. As the pH value increases, alkaline nature increases. Anyway, what is the best water? Drinking water should have pH between 6.5 and 8.5. So around 7, the pH of the water should be around 7. Then only we can consider that water is of a good quality and potable. Harbor basin water can vary between 6 to 9. So that is then low pH value help in effective chlorination, but cause problems with the corrosion. Corrosion means turubikia, rusting. So that is what is that is if you are transporting water through iron pipelines. If the water has high acidity, what happens is that these iron pipes will corrode, so that their life will decrease. So that is also another problem. So it is always important for the both people as well as for the government to ensure that the water the municipality is supplying is near the pH value of 7. So low pH or high pH is always harmful to people and also less profitable in long term for the government. Then the values below 4 generally do not support any living organism in the marine environment. That is, the pH value of the water is below 4. It means that most of the microorganisms may not be able to survive there. That is also another problem. Then another case is BOD. What is BOD? Denotes the amount of oxygen needed by microorganism for stabilization of decomposable organic matter under aerobic condition. That is, in a very simple way, DOB simply means, so in a very simple way, BOD means biological oxygen demand. High BOD indicates that more bacteria is present, and low BOD indicates that less population of bacteria is present. That is the practical or functional meaning of BOD, biological oxygen demand. That is, when too much amount of organic particles are there, they will be decaying, and decaying will be requiring lot of oxygen. So when we say that water has a high BOD, it simply means that too much amount of organic matter is present, so that available free oxygen, this is an amount of indication of how BOD will be working. So amount of BOD is an indication that too much BOD means less amount of oxygen present. That is a simple meaning. If water has high BOD, it simply indicates that fewer available oxygen is there. Most of the oxygen may be utilized by this kind of organic particle for their decaying process, and fish as well as plants and other aquatic organisms, they may not be able to get sufficient amount of oxygen for their life. So that is a problem of high BOD. High BOD simply means more organic particles in the water. So high BOD means less oxygen to support life and indicates organic pollution. So that is an indication of what is the importance of BOD. High BOD always means more organic pollution. Then third type is the bacteriological test. Under the bacteriological test, these are the primary test: fecal coliform test, total coliform test, and we will be checking for presence of streptococci. We will be testing for the presence of bacterial cyst of parasite. All these will be checked during the microbial or bacteriological test. For technical and economic reason, analytical procedure for detection of harmful organisms are impractical for routine water quality surveillance. That is, you have some amount of water in a water tank. It is not practically possible to check for the bacteria every time. That takes too much amount of time and also very expensive also. So the scientists have discovered some simple methods, and that simple methods are what we will be discussing. The result of routine bacteriological examination must always be interpreted in the light of thorough knowledge of water supply. So whenever changes in condition led to deterioration of quality of water supplied. So what is the importance of all this sentence is that here you can see that it is impractical to monitor drinking water quality for every possible microorganism. So we have selected certain parameters by which we can easily dictate or tell whether this particular amount of water, this particular sample of water is potable water. And for that, most of the time we will be taking what is called fecal organism. We just check for the presence of fecal bacteria. One advantage of checking for the fecal bacteria is that they are comparatively more easier than checking for the presence of other kind of bacteria. I will show you why. So it's a very easier method. So we don't need a lot of materials to check for the presence of fecal bacteria. Only few chemicals are needed. So checking for the presence of fecal bacteria, here you can see that checking for the presence of fecal bacteria is comparatively more easier than checking for the presence of other bacteria. So our assumption is that if fecal bacteria is present in water, then other bacteria will also be present in water. See, by using certain color test, it will be very easy to tell whether water contains fecal bacteria or not. So that is why we are always taking fecal bacteria as an indicator of bacterial contamination. If fecal bacteria is present in water, sometimes you might have heard in newspaper or TV, E. coli is present. So the presence of E. coli is an indication that water contains fecal bacteria, and if fecal bacteria is present, along with the fecal bacteria, other sorts of bacteria can also be present. So that is why we are using fecal bacteria as an indicator, and sometimes we use the term fecal indicator bacteria, because fecal indicator, if fecal bacteria is present, it indicates bacterial contamination. So this is, and then now we have different tests for fecal bacteria. The membrane filter technique uses a filtration apparatus and a cellulose filter called membrane filter. Here you can see that. So this is the membrane filter method. Now in this membrane filter method, this is how the system is working. There is a water sample and there is a filter paper here, and that filter paper is actually a membrane. Now water will be passing through that membrane, and if there are any bacteria, that bacteria will be filtered here and deposited in the membrane. And what we do is that, and we will be taking that membrane and we will be culturing it or incubating it. So after 1 week or few days, if any bacteria is present in the water, it will develop into bacterial colonies, so that it will be easier to detect. So that is a technique that we are using in this membrane filter method. So membrane filter method is a very popular method for detecting the presence of fecal bacteria. What we do is, this is how we will be just allowing water to pass through a membrane filter, and bacteria will be deposited in the membrane filter, and that bacteria will be cultured. So this is the idea in membrane filter method. So here you can see the 100 ml sample of water is passed through a filter. Filter pad is then transferred to bacterial growth medium, as I have shown here. So whatever bacteria which are present in the filter paper will be then cultured, and they will be counted. So here you can see that, here we can find that here the how many 1, 2, 3, 4, 5, 6, 7, 8 colonies are there. So if the number of colonies are beyond a certain number, the scientists will say that this water is not suitable for drinking. So that is how we are normally checking the quality of the water. So here this is always also known as membrane filter technique, millipore filter technique. Millipore filter means process a uniform porosity or a determined pore size of 0.4 micrometer. That is size of the holes in the filter paper. That is 0.4 microns. That is it. The pores in the membrane are sufficiently small to trap different types of microorganisms. So what we are saying, this is even though it appears like a paper, it has a lot of holes. Through that holes, bacteria cannot pass through, but water molecules are still smaller, they can easily go through. So that is the technique or principle behind the membrane filtration technique. So membrane filter technique can define the process of microbiological analysis of water by making use of special filter like membrane. So this idea is same. So this is one of the best technique for water analysis. Advantage is that large volume of water can be checked within a small amount of time. So that is the biggest advantage of using the membrane filtration technique. Then here also you can see that the water are passed through that. This is the bacterial membrane filter, and whatever my bacteria are there, they will be trapped here. Only water will be passing through the filtration. Then So this is also the same thing. Then another type of technique is known by the name standard plate count. This is another technique that we are using. So in this of standard plate count, samples of water are diluted in jar containing 99 ml of sterile water, and samples are then placed in petri dish with the nutrient agar or nutritious medium. So I will explain how this all process is working. See here we have a sample water and we take 1 ml, this is 10 ml of sample water. From that 10 ml we take 1 ml of water and we add it into another test tube. So, and after adding 1 ml of water we will be adding 9 ml of plain water. So 9 ml plus 1 ml. So the dilution is 0.10. That is 10 to the power of minus 1. That is 0.1 times it is diluted. Then next what we do is that we take 1 ml of water here and add it to the tail test tube, and again we add 9 ml of water. Then dilution become 0.001. So that is it, or 10 to the power of minus 2, or 100 times it is diluted. Here it is diluted 10 times, here it is diluted 100 times. Now we repeat the same process. Here you can see that it is diluted 1000 times, here it is diluted 10,000 times. So this is how the system is working. Now what we are doing is that we will be collecting bacteria from that, and we will be collecting bacteria and growing it in a petri dish. Then we will be collecting also from the 100 ml 100 diluted sample, also from 1000 diluted sample, also from 10,000 diluted sample. The idea is that when we are checking for the presence of bacteria, here you can find that 1, 2, 3, 4, 5 colonies are formed. Then in the next one also 5 colonies are formed. In the third one, 1000 dilution sample also we can find 5 colonies. 10,000 also we can find 5 colonies. Idea is to increase the accuracy of testing. Actually only one testing is sufficient, but to improve the accuracy we are diluting it 10,000 times and we are again checking. And if the number of colonies in all these are 5, we can prove that, we can show that our test is highly accurate. So that is the advantage of standard plate count. And similar kind of technique is, so here samples of water diluted in jar containing 19 ml. So there is a serial dilution technique is applied. Then a similar kind of technique, so this is also working on the same principle, most probable method. In the most probable method, tubes of lactose broth are inoculated with the water sample containing 10 ml, 1 ml and 0.1 ml. And during the incubation, coliform organism produce the gas. So here you can see that. So this is how the next method is, most probable method is used. Here you can see that this is the original water sample. We inoculate 10 ml in each tube. So from this we will be inoculating only 10 ml from this this conical flask and transferred to each of the test tube. Here 0.1 ml will be transferred to each of the test tube. Here only 0.1 ml is transferred. Now we will be incubating, keeping it at 37 degrees centigrade for 24 hours. And if you are finding production of gas, if you are finding the production of any gas, it indicates that bacteria is present. So that is how we are actually doing the most probable method. If there are more pictures are available, I will show you. No, there is no most probable. So there is no other picture. See, the same picture is here also only available. So our main idea is that we will be transferring water in a serially diluted quantity and we will be checking for the production of gas. If gas production is taking place, we can say that there is bacteria present. Why we are using 10 ml, 1 ml and 0.1 ml sample is that to check, to increase the accuracy of testing. So that is the purpose of most probable number method in water purification, water quality testing, and standard plate count, and also the membrane. So there are three primary methods for bacteriological testing. So if there are any other techniques, we will also check. See here you can see that other methods are. So this is how they are actually conducting this test. Video is there.